Here we'll look at a final example of the ambiguous case in using the law of signs. So remember, there were three possible ambiguous scenarios where you could get no triangles at all, you could get two triangles, or you could get one triangle. And so here we have the case where only one triangle will exist. So let's start by drawing it in the given conditions. So I've got an angle A, which is 40 degrees, and I've got the side opposite given as 3. I've got an angle B, which I can put anywhere I want, just as long as the side opposite is 2. And then I have an angle C and a side C where I don't have any information. Once again, I'm given two sides and one angle, which verifies the ambiguous case. Okay, so first thing we want to do is solve for an angle. So just like in the last two examples that we've looked at, we're going to try to use the law of signs, and we're going to have to use an inverse. Okay, so we need the sine of an angle over its opposite side, 40 degrees and 3, and we're going to set it equal to the sine of B over 2. Again, we don't have any information at all about C, so if we tried to use C here, we'd have two variables, and that wouldn't work. Don't forget that these can be flipped around. These ratios can be on opposite sides, and they are equivalent, so it makes no difference. All right, let's cross multiply and solve. So we'll have 3 times the sine of B equals 2 times the sine of 40 degrees. And if we go ahead and isolate the sine of B, remember these come as a pair, so you've got to get that all alone first. And then remember how we will get rid of the sine, since we're trying to ultimately just solve for B, is we will inverse sine both sides. Okay, so that gives me an angle B, which I can find by doing the inverse sine of 2 sine 40 degrees over 3. So let's figure out what that value is. And using my calculator, I get B is approximately equal to 25.37 degrees. Alright, so that's one possible triangle, or one possible angle for that triangle. Let's check for multiple triangles. Alright, so the way that we're going to check is that we're going to see if, given the two angles that we have, do they really create a third angle for this triangle. So we've got a 40 degree angle in either scenario. The angle we just solved for was for B, 25.37 degrees. Remember how we find the other option for that angle. So B1 is 25.37, B2 is 180 minus that angle. So we're finding its supplementary angle, and we get 154.6 for that angle. Now, let's use the fact that triangles add up to 180 to solve for each of the missing angles. And if they both work, then we know we have two triangles. If only one of them works, then we only have one triangle. Okay, so I'm using my calculator here to do the subtraction from 180. And down here, I'm going to get 114.63 degrees. So that triangle definitely works. That forms a triangle. Let's look at the second one. If we take 180 and subtract 40 and subtract 154.6, we're going to get negative 14.6 degrees. And so that is not a reasonable solution. So this is not going to form a triangle, which means that we only have one triangle in this ambiguous scenario. So let's continue solving. So remember, we were trying to find angle B, which we know has to be 25.37 because the other option doesn't produce a triangle. We were also needing to solve for angle C, which we found was 114.63 degrees. And the last piece of information that we needed to know was side length C. So in order to solve for that final side, we're going to once again do the law of sines. So the sine of 40 degrees over 3 equals the sine of 114.63 over C. So remember, this has to be the angle opposite of C. Cross multiply and solve. And you may want to pause just to make sure that you can solve and get that answer, but it looks like that third side is 4.24. Alright, so we've looked at all of the possible cases. Let's just do a quick review of what we have. So for law of sines, we have triangles ASA, we have triangle AAS. These are just straightforward law of sines. So you need to use 180 degrees to solve for your third angle. And then you need to use the law of sines to find the other two sides. So you'll have to use the law of sines twice, once for one of the sides and then a second time for the other side. Then we have the ambiguous case. Which means based on the given information, we don't know what type of triangle will be formed, if any. So we have no triangle. We have two triangles, or we have one triangle. And so we'll know that we have no triangle if we go to solve for one of the angles and we get an error in the domain. That means that that triangle doesn't exist. Then, in another scenario, we might have two triangles or one triangle. If we're able to solve for that first angle, we need to check the second angle to see if it forms a triangle or not. If you're able to come up with two triangles, then both answers will have to be given for both triangles. And then if you only have one triangle, then you proceed from there. So that is a review of the law of sines. You may also have some application problems, which are basically just word problems, where you'll have to either set up the diagram or, given the diagram, set up the equation in order to solve. And remember that these are for non-right triangles. Now, just as a heads up, we will be looking at some other triangle types. So here we list 3 different possible triangles in terms of what's given. There is also a scenario where you're given 3 sides, or you're given 2 sides and then the angle in between, And there is another formula or another law that we can use in those scenarios called the law of cosines. And so that will be done next week on Wednesday in class in section 9.3.